All right, good people. So we'll be continuing with Euclidean, and obviously we'll finish maybe in an hour or so, depending. Obviously, I'm going at your own pace. If you want me to be fast, I will be fast. But if you want me to be a bit slow, I'll do that as well. That is the whole reason of having this online session, right? To ensure that everyone understands and no one is in a rush. So the last thing we did on Euclidean, we covered the lines and we also covered the triangles. And under triangles, what we covered is congruency and similarity. And we explained the difference between the two. And we went on further to say that similarity at this stage, it's not that it's not important, right? But they don't ask much of it. And then I even went further to tell you about the importance of labeling the triangles in a correct way. So if we can quickly go to that, right? Let's assume that you were given triangle, sorry, okay. Let's say you were given triangle A, B, C, and you were given triangle KJL, right? You remember that on Saturday, when we were doing it, we were utilizing this method of first, second, and last. Sorry? Good people, if you're not talking to me, mute yourself. Don't force me to mute you. So we said that AB would be equal to side KJ, right? And this will only be true if you see it in your diagram and you see the reason why. So if we were to apply this concept, if you apply this concept in similarity, because the way I showed you, we were applying it in congruency, right? Because remember, I told you that in congruency, you only need 3 reasons for you to prove or for you to conclude that these two triangles are congruent. And we said those reasons can be side, 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 can be side, angle, side, it can be right hypotenuse side, and it can be angle, angle side, right? So when it comes to similarity, remember we said that similarity deals with what? With proportion. And I said proportion is basically your ratio. So if we were to prove that these two triangles are similar, you'd say AP all over KJ, right? Remember we said first and second, right? Is equal to second and last, which is BC, all over second and last here, which is JL. And this is also equal to what? First and last, which is AC, all over first and last, which is KL. This is when you apply it in what? In similarity. I don't want you to confuse these two. If they ask you anything related to similarity, obviously, and this only applies if you're dealing with triangles, right? If you're dealing with a quadrilateral, obviously you'll be having like 4 angles. So you don't apply this method of first and second. No, it only applies to triangles. And I'm saying that when it comes to you proving the similarity, you say first and second, which is AB all over the first and second of the second triangle. But if you are applying this method in congruency, you don't say AP over KJ. You say AP is equal to KJ. I hope that makes sense. And I'm not confusing anyone.
Yes, sir.
Everything makes sense. All right, I'm happy. Now, if that makes sense, then let's quickly go to the example I gave you on Saturday when before you left, right? And surely you still have it in your group. So we had a quadrilateral, right? We were given something of that nature. And then we were told that this is S, this is R, this is P, and this is Q, right? And then we were told that these two opposite sides are parallel, even these ones, right? And the first question asked us to prove that PQ is equal to RS. right? So we're supposed to prove that PQ, this side, is equal to this side, right? So the only way we would prove that, I don't know if you see what I'm seeing, but we have two triangles, right? Remember, at this point, we haven't touched the quadrilaterals. And even if we did touch the quadrilaterals, we wouldn't be able to say whether this it looks like a parallelogram, right? It is a parallelogram, but based on just the reason that these opposite sides are parallel, even those ones, right? But that's not enough, right? When you are supposed to prove that this PQ is equal to this SR, we can utilize those two triangles, right? We have triangle number 1 here, we have triangle number 2 here, right? So the first thing, remember, always when you're dealing with triangles, it's important for you to ensure that you label them correctly. And if I remember correctly, on Saturday, I said to you, you ensure that if you have a common side, meaning that you have triangles that share a side, you always start labeling those triangles based on the side they share. So in this case, and I even told you on Saturday that that doesn't work every time, right? If it doesn't work, then you have to change, right? It's either it does work or it doesn't, right? And if it doesn't work, you'll have to change and rearrange how you are going to label that triangle, right? This is a great example of what I was telling you. So we can see that the common side here is going to be PR, right? Because we have two triangles. We have SPR, right? Which is this one. And then we have PQR, right? Then we have this triangle, which is PQR. So we can see that both triangles, share the side PR, right? Because we have PR here, we have PR here. So if we start by labeling this side to say we have triangle PR, and this side also, this starts with triangle PR. Obviously here, if we take PR, the only side that will be left is S. So we'll be having triangle PRS, and on this triangle, we'll be having PR and Q, right? At this point, you would be happy because you'd say PR first and last, which is this one, and first and last. So PR will be equal to PR, which is common. You are correct, right? And then you see that you take the second and last, which is RS, right? Which is RS, which is this one, and then it will be equal to RQ. So if you check here, there's no way RS will be equal to RQ. There's no way this side will be equal to this side, right? So before you can even write, you can already see that this labeling is not the correct one, right? Yes, we started with the common side, which is PR, but it only gave us that side, which is PR. It is failing to give us other sides, right? So then how do you maneuver this one? You're going to simply go to your to the diagram that you're given, and still PR has to be equal to PR because it is the same side, right? But now what we can do, they will always, if this method of you starting with the common side is failing, you check what is it that they ask you to prove. Most of the time, if not always, what they gave you is the hint as to what, how will you start labeling your triangles. What am I saying? You can see that they started by PQ and RS. So you'll start by saying that in triangle PQ, if I take PQ, which triangle has PQ between two triangles? Obviously, it's this one. So if I take PQ, I'll be left with R, right? Because I have PQR, right? So that is the name of this triangle. And then I will say, and this one has to start with RS. So if I take RS here, I'll be left with P. I hope that makes sense, right? So already we know that we'll be having these two triangles. There's no way both methods will fit. So we have RSP, right? So that is how you would go about labeling those triangles. I hope that makes sense and I didn't confuse you in any way. So I will repeat quickly. If the method of you naming the triangles based on the fact that you're going to start with the common side, if that doesn't work, you must check that before you can even answer your questions. If it doesn't work, then you quickly start with what you're given. What you're given most of the time will be a hint as to how you're supposed to be labeling the triangles that they want you to focus on. I hope that we are still together, right? Remember that the question is still for us to prove what PQ is equal to RS. At this point, before we can even finish proving, myself, I'm happy because I'm seeing that PQ is first and last, and RS is first and last. It's first and second. This one is also first and second, right? Which approves because it is PQ is equal to RS. That is what we want to prove, right? So meaning that we can start with that one. But there's something that is very, very interesting, right? We take the first and last, which is PR, and first and last, which is RP, and PR is one and the same thing, right? So our first statement, we say PR is equal to PR, and the reason for that is what? It's a common side, right? It's a common side found on both triangles. Done with statement 1. We need statement 2. Statement 2, obviously, we can say PQ is equal to RS because that is what we're supposed to prove. So we leave that one. We are trying to prove that, what do you call it? And we can also prove that QR is equal to SP because there's nothing that gave us something that has to do with what? With angles, right? But there's something that is interesting. You see we have P here, we have R here. We have P, we have R, right? So it means that this angle of P has to be equal to that angle of R, right? And on top of that, what did I say when we were doing the lines? I said, always when you see parallel lines, the first thing that should come to your mind is what? Math is fun. So we see corresponding, alternating, and co-interior, right? So obviously here, you can't utilize co-interior because we were not given any angles. So there's no need of you saying that this angle plus this angle is going to give you 180. That's useless at this point. It won't help you in any way, right? And we don't see any corresponding. So the only thing that we can use here is the alternating angles, right? So which alternating angles? We are going to say, let's say this was 1, and this was 2, and this was 1, and this one was 2, right? We are basically, we know already just by labeling our triangles that the angle of P has to be angle of R. Which one? Then we go to our diagram. You can see that we have Z here, right? Going this way, right? This is our Z, meaning that this angle is going to be equal to this angle. Why? Because these two lines are parallel, right? So we are going to say angle P1 is equal to angle R2. And what is the reason? Alternating angles. And remember, always when you state that, always when you have parallel lines, you state either corresponding, co-interior, or alternating. You must always state which lines are you focused on, because we have this line being parallel to that one, and then we have this line being parallel to that one. So you must be specific exactly which lines are you talking about. So obviously we say it's PQ, which is parallel to SR, because that is what we used. I hope that makes sense, right? So it will be PQ parallel to SR, right? So PQ parallel to SR, right? So we have first statement, we have second statement. We are left with the last statement, right? Last statement for us to have congruency, because congruency needs how many reasons? 3. So another thing that we can see is another Z, right? We have another Z which is going like from S, P, R, and Q, right? This is the other Z. So this angle will be equal to this angle. Let me erase this. Right? I hope that makes sense. This angle P2 is equal to angle R1. And the reason for that is what? Alternating angles, right? And besides, how did we know that? Again, we come back. We knew that angle P has to be equal to angle R, right? And because we were given a diagonal connecting the two, That made life to be simple. So already now we know that angle P2 is equal to angle R1. And the reason for that is alternating angles, but now which lines are parallel? It's PS, right? It's PS being this one here. PS is parallel to QR, right? You must write that here. So it's going to be PS parallel to QR. So already we have three reasons, right? It's the one that talks about the side, this talks about an angle, and this talks about an angle. And in one of the congruency reasons, we have that reason of angle, side, right? So then we can conclude to say that triangle PQR, right? This triangle is congruent to triangle RSP. What is our reason? Our reason is angle, side. We have proved that we have two angles which are the same and one side which is the same on both triangles. And remember, we said that when we are saying something is congruent, we are basically saying that it is exactly the same. So if you're saying something is exactly the same, then it means that if these two triangles, if this triangle is exactly the same with that one, then it means this side, which is SR, which is of this triangle, and that side PQ, which is of that triangle, they have to be equal. Why? Because these triangles are exactly the same. How did we know that they're exactly the same? We just proved it, right? So we can conclude to say that PQ is equal to RS, right? It's proven that these two triangles are congruent. Does it make sense? Did I lose you someone?
Understood.
Everyone understands?
Understand? Yes, sir.
Yes, sir. I understand.
I'm happy. Now, the second question then says we have to prove that PS is equal to QR, right? We have to prove that PS is equal to QR. So obviously, if we have to prove that PS is equal to QR, where already we know that this one is equal to that one, right? Now they want us to prove that this side, which is PS, is equal to that side, which is QR. There's nothing to prove here, right? On B, this question, if it was to be on your exam, it would just be one, right? And I always tell you that the marker location should be a guide, right? It should give you a guide as to how much time you should be spending on the question. And then secondly, how many steps roughly you should have, right? So since this one would be 1 month, and obviously it is still referring us, please mute yourself. Someone is making noise. Oh, thank you. So now what we basically do, we know that this one is PS and this one is QR, and it's still part of this triangle. PS is part of this triangle, and QS is QR, I meant to say, is part of that triangle. So obviously what you basically do is write PS is equal to QR. And the reason is it's proven that those two triangles are congruent, right? Because check where PS is, right? PS is last and second, right? Last and second. I hope that makes sense. So there you don't have to sweat. The only thing you have to write is that PS is equals to QR, and your reason is it's proven. Or your reason can be congruent triangles. Actually write congruent triangles, because if you say it's proven, it really doesn't make sense. What is proven? So your reason will be congruent triangles. Does it make sense?
Yes, sir.
All right. So
Yeah.
now, good people, what I want is, I basically wanted to give you more problems, right? So when you come here, we deal with only the solutions. Because I know if I was to give you problems now, then it would be a problem because you'll take time and Zoom normally, mine, because I'm not paying for the whole thing, it takes like 40 minutes, then it will kick us out and stuff. So I wanted to utilize the 40 minutes, and then you'll let me know after that 40 minutes if you still want us to continue or what. So what I'll basically do, should I give you one more example, or should we go to quadrilaterals?
So one more example. One more example.
I want to give you something that is challenging. Or maybe I should spare the challenging ones for you to do alone. It's fine. So, no questions, good people.
No, sir.
You clearly understand everything.
Yes.
It's 55 degrees there. Né? Don't say you didn't see. We have D1 and 2, and they tell you that the whole of this is X, right? The whole, meaning D1 plus D2 is X, right? It's basically, oh my. So D2 is this one, right? And then they tell you that this is parallel to that. And then 73 there. Now, what I'm trying to do here is to see if you can apply everything I've told you so far. And then you have Y there. Yeah. It's clear, right? You can see everything. And obviously the question is for you to find the value of X and Y. You are being told that A angle DC, right? A angle DC is equal to X. I've already indicated that for you in the diagram. So can anyone give us a hint? Where would we start by saying what and why? Because we said that in Euclidean geometry, always you must have a reason for everything. So remember that
X is equals to 27 degrees.
Sorry?
X is equals to 27 degrees alternating angles.
X is 27. Okay, check. Hence I wrote what I wrote here. A angle DC is the whole of this angle. D1 and D2 are giving you X, not just D2. Does it make sense?
Yes.
A is here, there's D, so the whole of this is X. But in this is divided into 1 and 2. But the whole of this is X, not just D2. Hence I wrote angle A DC is the one which is X, not D2 is X. Does it make sense? So meaning for you to get X, you must first find D1, find D2, add them together. Then that is how you get X.
So, sir.
Yes.
For D1, aren't we supposed to, I get it out of, it's a supplemental.
Angles?
AED.
Yes, you are correct. You are saying we're adding A and
we add the, yes, and then we sub, and then that amount we subtracted from 180 to get D1.
And what's the reason?
What's the reason?
Yeah, you're correct. You are going to do that. What's the reason for us to do that? Remember, you must always have a reason. Because what you're basically saying is that you're going to say angle D1 plus 55 plus 73 is going to be 180 degrees. So I'm asking what is the reason? Sorry?
Angle
Sum of
Sum of
interior angles of a triangle is equal to 180.
Sum of interior angles of a triangle. That's the reason. Now, from there, you just take your calculator. What is D1? Obviously, you'd have to write that D1 is equal to 180 minus the sum of these. But I don't have space. Sorry?
D1 is equal to 52.
D1 is 52. 52. So now that we know that D1 is 52.
Isn't it's 52?
Yeah, it's 52. Someone said that D2 is going to be 27 degrees, right?
Yes. So
We all agree.
Yes.
Yes, sir.
Yes.
So D2 is equal to 27 degrees. And the reason for that is
Alternating.
Alternating.
which lines are parallel?
C and D.
CD.
ED is
D
parallel
and
to
CD.
CD. CP.
Oh, yes.
So we are sorted. We know that this one is 27. We know that that one is 52. And they said that A angle DC, that is X. So meaning that basically X is equal to 52 plus 27. So what's the value? 79.
79.
Done.
Yes, 79 degrees.
We are happy with that. Right? Does it make sense?
Yes. Yes, sir.
All right.
Yes, sir.
We are left with one, which is Y. What is the value of Y and Y?
Isn't it gonna be for D2?
What is the value of Y? 2 marks. Let's say it was 2 marks. So I'm just giving you a hint that you don't have to do a lot of things. It's 2 marks. We just need a statement and a reason. We are done.
98.
Nope.
52.
52, yes, you're correct. How did you find that it was
52.
The
Corresponding angle.
Thank you.
corresponding angles.
Thank you. So we can see that here we have an F, right? We have something like this. This angle is equal to that one. So here we found that D1 is 52, right? So even this one is going to be 52. And the reason for that is corresponding angles.
Corresponding.
Yes. So you can see that in this kind of problems, if this was wrong, then it would mean that you even have a wrong answer, right? Which was going to be a disaster. So this was very simple, right?
Yes, sir.
All right. Now, okay, good people, the meeting will end in like 5 minutes. So I want to find out from you if after these 5 minutes you join again, but you should join again. Are you all fine with joining again?
Yes.
Yes, sir.
Okay.
Yes.
So let me give you a problem and then we do it as soon after these 4 minutes, it will automatically kick us out. And then you join using the very same details I gave you. Every time when I say we have a Zoom meeting, you use exactly what I gave you. I won't send anything new, any new meeting ID. You will always use that one. If I say I have a meeting, whether it's one-on-one or as a class, you use that always. So,
Okay.
I want to make this thing interesting. Just a bit hard.
So make it hard.
Yeah, I have to make it hard. It has to be hard. But this one is not really hard. Okay. All of you are using another device or you're using your phones, because if I send it on WhatsApp, will you be able to be on WhatsApp and be on the meeting at the same time?
Yes.
Yes.
Okay.
Yes.
Right. So I want through it. I'll send it on WhatsApp, right? It's on, yeah. So let me end the meeting and then send, I will ask you to join in, like in 2 minutes. As soon as you are out, I will kick you out, come back. And then I will give you like 5 minutes, then we start.
Great.